Section 1.1, Angles, Degrees, and Special Triangles. In this section, we have two objectives. The first objective we're going to look at is identify the complement and supplement of a given angle. An angle is formed when two rays have a common endpoint. The common endpoint is called the vertex of the angle, and the rays are called the sides of the angle. The symbol theta, which is this circle with a line through it, is a variable used to represent an angle. So when we think of theta, all right, we are thinking of a measurement, a degree measurement that is formed by two rays, as you see here in figure 1. Okay, so this angle theta is being formed by the rotation of this ray OA, which is the initial side, to the terminal side OB. Okay, so that formation, that movement of the array to that location then creates the angle theta. So when the rotation of the initial side to the terminal side occurs counterclockwise, the angle formed is called a positive angle. If the rotation is in a clockwise direction, then the angle is a negative angle. 1 degree of angle measure is written as 1 with the degree symbol and is 1 over 360 of a complete rotation of a ray around its endpoint. So if we have an array and it goes all the way around, that's 1 complete rotation, as you see here in figure 3, and it creates 360 degrees. So there is 360 degrees in 1 full rotation. So if we were to look at half of a complete rotation, it would be 180 degrees. And then if we looked at a quarter, it would be 90 degrees. So these rotations then create 4 different types of angles that we're going to look at. The first one is called the right angle, and this is a 90-degree angle, an exactly 90-degree angle. Okay. The second is a straight angle, right? So a straight line, and this represents an exact 180 degrees. So that's half of a rotation. Now, if we have an angle measurement that is less than 90 degrees, we call that an acute angle. And if we have an angle measurement that is between 90 and 180 degrees, then we call that an obtuse angle. If two angles add up to 90 degrees, so that would mean if it creates a right angle, they are called complementary angles, sorry. So for example, if one angle is 40 degrees, the complement would be 50 degrees, because if we were to add 40 plus 50, we would get 90 degrees. If two angles add up to 180 degrees, they are called supplementary angles. For example, if one is 120 degrees, and the supplement would be 60 degrees, because 120 plus 60 equals 180 degrees. Okay, so if you have two different angles and they add to 90, they're complementary angles, and then those two angles are complements of each other. And if you have two angles that add up to 180 degrees, then they are supplementary angles, and they are supplements of each other. So if you're asked to find complements and supplements, you can follow these directions. So to find the complement of an angle, you would subtract from 90, and to find the supplement of an angle, you would subtract from 180. So let's do a couple exercises here. The directions tell us to give the complement and supplement of each angle. So the first angle that we're going to look at is 25 degrees. So to find the complement of 25 degrees, we're going to follow these directions and subtract from 90. So 90 minus 25 equals 65 degrees. So the complement of 25 is 65. To find the supplement of 25, we're going to subtract from 180 degrees. So 180 minus 25 equals 155 degrees. Okay, so we found the complement. I'll just label this C, and we found the supplement. Okay, now let's look at the next angle, 118 degrees. So to find the complement, we will subtract from 90. So this is the complement. So 90 minus 118 is negative 28 degrees. Then the supplement, we would subtract from 180 degrees, and we will get 62 degrees. And then for our last example, we're given the angle beta, so that's just a symbol that represents a value. So to find the complement of beta, we would subtract beta from 90. So that would be 90 minus beta would be the complement. The supplement, we would subtract beta from 180 degrees. So 180 minus beta, let's rewrite that beta. There we go. Would be the supplement. All right, so now we've completed objective number 1, or letter A. So let's go on to the second objective, and that is solve problems involving special triangles. So special triangles are right triangles with specific angle measures that allow us to find side lengths using known ratios. A right triangle is a triangle with an interior angle of 90 degrees, which makes sense because we know that a right angle is a 90-degree angle. So if I have a triangle that has 90 degrees, then I would be considered a right triangle. The side opposite the right angle, all right, so this is our right angle here. So the side opposite our right angle is called the hypotenuse, and the other two sides are called the leg. Let me erase that. They're called the leg. So we have leg A here, and we have leg B here. Now the Pythagorean theorem states that in any right triangle, the square of the longest side, which is the hypotenuse, is equal to the sum of the squares of the other two sides. So that would be leg A and leg B. So that gives us this lovely formula. C squared equals A squared plus B squared. You might also see it as A squared plus B squared equals C squared. You can write it either way. Okay, so the square of the hypotenuse equals the sum of the square of leg A and leg B. So we can use this theorem to find the sides of a right triangle. So if we're given two sides, we can then find the third using this theorem. So that in this example, we're asked to solve for x in the following right triangles. So we have this example and we have another one. So we know that we have our 90-degree angle right here. which means the side across from it is the hypotenuse, and I'm going to label that C. Then my other two sides are going to be the leg, and I'm going to label x minus 3a and xb. That way I know what to substitute into my formula. So I have the formula here, a squared plus b squared equals c squared. And I'm going to substitute in my known expressions for each letter. So my a is x minus 3 squared. My b is x, so that'll be squared. And my c is 15 squared. Okay. So now I can simplify. So x minus 3, I'm going to have to use FOIL to distribute. So I'll get x squared minus 6x plus 9. Then I still have my x squared. And then 15 squared is 225. I can combine like terms. So I'll have 2x squared minus 6x plus 9 equals 225. I then want to get my quadratic here in factored form, but in order to do that, I need to make sure that it's set to 0. So I'm going to subtract 225 to the left side. So that will give me 2x squared minus 6x minus 216 equals 0. Okay, so now I can put this in factored form, but I want to simplify it a little more. Each of the coefficients on the left side are all divisible by 2. So I'm going to divide everything by 2. And I get 108. And now this is in a more simplified form, which will then allow me to distribute this a lot quicker. Okay, so I know I have x, so I need two values that multiply to get 108, add to get 3. So that will be 9 and 12. And 9 would be positive, and this would be negative. Okay, so now I can set each factor equal to 0. And I'll get x equals negative 9 and x equals 12. Okay, so our exercise here is asking us to solve for x, not to actually solve for the values for the lengths of each leg. So I have two options here for x. I have negative 9 and 12. Now, if I were to substitute negative 9 into each of the expressions for the legs, I would get negative 9 for B, and I would get negative 12 for A. Now, when you're speaking of lengths, right, we know that when we need to state the length of something, it's always going to be a positive value. Like you can't be negative 5 feet, or the worm can't be negative 3.5 feet. Or, ooh, that would be a long worm. Anyway, inches or centimeters, I guess, would be more appropriate for a worm. So, negative 9 cannot be our answer for x because it is negative. Now, if we were to substitute in 12, those values seem more reasonable, so x here would be 12. And if we plug in 12 for x minus 3, we would get 9. Okay? And so we know the longest side is still the hypotenuse, and then we have our two legs, 12 and 9. So for our solution, since a side cannot be negative x equals 12. Okay, all right. Let's do our second example here. And so now our lengths have unit measurements, so we know we're dealing in feet. So we have a 90-degree angle here. So the side across from the 90-degree angle is our hypotenuse. So that will be our C. Then we have our two legs. I'll give this leg A and this leg B. And so now we're going to find our missing side, which is x feet. So starting with our formula, x squared plus b squared equals c squared. I'm going to substitute in my given values. So for A, I have 1355 squared plus b squared, which is my x, and then c is 6230 squared. Okay. And so because these are bigger values, I'm just going to manipulate this formula so that I have the variable x by itself. Now, you are more than welcome to simplify each term and then do the same process like we did on the last problem. So I'm going to first start by getting x squared by itself. So to do that, I'm going to have to subtract the 1355 squared to the other side. So that'll be 6230 squared minus 1355 squared. To get the variable x by itself without a square, I have to take the square root. So I'll take the square root of 6230 squared minus 1355 squared. And I would then substitute that right side expression into my calculator. And I will get the value 6,080.86137. Since my triangle has values rounded to the nearest foot, I'm going to round x to the nearest foot, and that would be 6,081 feet. Okay. Now this theorem, the Pythagorean theorem that we've just worked with, is essential for solving problems involving special triangles. And the two most common special triangles are the 30, 60, 90 triangle and the 45, 45, 90 triangle. So in a 30, 60, 90 triangle, the sides have the following ratio. So we know that we're dealing with a right triangle because we have a right angle, and the other two angles are 60 and 30, as you see in figure 10. The side opposite the 30-degree angle is the shortest side. So in our figure 10 here, we have 30 degrees here at the top. So the side opposite is the shortest side, and we give that the variable t. Now the side opposite the 60-degree angle is the square root of 3 times the shortest side. So that's why we have t square root 3 as the expression for the length of that side. And then the hypotenuse is 2 times the shortest side. Okay, so that would be 2t as the hypotenuse. So if we're given any of the side lengths in this special triangle, and we know it's a 30, 60, 90 triangle, we can find the missing side lengths. So let's do that. So if the longest side of a 30, 60, 90 degree triangle is 14, find the length of the other two sides. So I know I'm dealing with a 30 60, 90 triangle. So I'm going to set up my triangle here, and I'm going to match it to our example in the corner here. So I have 60 at the bottom, 30 at the top, and my right angle. So I know the longest side is 14, and the longest side of a triangle is the hypotenuse, so that's going to be here. And I now need to find the other two sides. So I know this side is t square root 3, and I know this side is t. Okay? So what's special about the hypotenuse of a 30, 60, 90 triangle is that its expression is 2t. And I know what 2t equals. Well, 2t equals 14, because that's what it said here in my problem. The longest side is 14, and the longest side is the hypotenuse. So since I know what 2t equals, I can find t. So I'll divide both sides by 2, and I get t equals 7. And I also know what t represents in my triangle. That is one of the sides of our 30, 60, 90 triangle, and it's more specifically the shortest side. It's the side opposite the 30-degree angle. So I now have found one of my sides. I can find my last side, which is expressed as t times the cube root of 3, which would be 7 times the cube root of 3. So the two lengths of my two missing sides are 7 and 7 square root 3. Okay, let's do another example. So a ladder is leaning against a wall. Okay, the bottom of the ladder makes an angle of 60 degrees with the ground, and it is 3 feet from the base of the wall. How long is the ladder, and how high up the wall does it reach? So we know we need to find two things. We need to find how long the ladder is and how high the ladder reaches on the wall. So let's draw a visual to help us out. And again, I'm going to draw the visual to match our image in the corner. So we have a ladder that's leaning on a wall. Okay, so let's draw our ladder here. Is there a ladder? And it's leaning on a wall. Okay, and the bottom of the ladder makes an angle of 60 degrees with the ground. So this right here is 60 degrees. Okay, and it is 3 feet from the base of the wall. So we know the wall is on this side, and it makes 60-degree angle, and it's 3 feet from the base of the wall. So that's the distance it is. We want to know how long is the ladder. So we want to know this distance over here. And we want to know how high up the wall does it reach. And so we want to know this distance over here. So what do we know? Well, we know we're dealing with a 90-degree triangle, a right triangle, a special triangle of 30, 60, 90. Okay. We know one side is 3 feet, and that also happens to be the shortest side. So we know t. So we need to find how long the ladder is, and that is going to be 2t. And we need to find how high up the wall does the ladder reach, and that is t square root 3. So since we know t as 3, we can find t square root 3, which will equal 3 square root 3, and we can find 2t, which would be 2 times 3, which equals 6. So the length of the latter is 2t, and 2t equals 6. So that will be 6 feet. Okay, and then the height of the wall is going to be t square root 3, which would be 3 square root 3 feet. Okay, that would be the exact answer if we were asked to approximate. Let's do the approximate symbols. If we were asked to approximate, that would be 5.2 feet rounded to the first decimal. Okay. All right. Okay, so let's look at another special triangle. So in a 45, 45, 90 degree triangle, the sides have the following ratio. Okay, so we know it's a right triangle because we have 90 degrees. It's special because we have two angles here that equal 45 degrees. And because of that, our two legs are equal. So our two legs, A and B, are going to have the same value. And our hypotenuse, which is the length across from our 90 degree angle, is the square root of 2 times the length of the leg. So t square root 2. So in our exercise here, an 8-foot rope connects the top of a tent pole to the ground. If the rope makes an angle of 45 degrees with the ground, find the length of the tent pole. Okay, so let's draw our image. So we have an 8-foot rope that connects the top of the tent pole to the ground. So we have a pole and a rope that connects the top of the tent pole to the ground, and it is 8 feet. Okay. If the rope makes a 45 degree with the ground, so it makes a 45 degree with the ground, 45 degrees, so this would be 90 degrees, which would make this, so 45 degrees. Find the length of the tent pole. So we want to find this length right here. Okay, so this is a special triangle. It's a 45, 45 degree triangle. So we know then that our two legs are both going to be the same. So they'll both be t. We also know that the length or the side across from our right angle is our hypotenuse, and our hypotenuse equals t times the square root of 2. So that means t times the square root of 2 equals 8. So I can find t by dividing both sides by the square root of 2. Okay, to get the square root of 2 out of the denominator, I'm going to multiply the top and the bottom by the square root of 2. And that simplifies to 8 square root 2 over 2, which I can simplify some more because 8 divided by 2 equals 4. So that means t equals 4 square root 2. So the two sides, or the two legs of our 45, 45, 90 triangle is 4 square root 2 feet. So we are asked to find the length of the tent pole. So the length of the tent pole equals 4 square root 2 feet. So that would be the exact answer. The approximate answer would be 5.7 feet. Okay. All right, next exercise. So we have a 60-foot flagpole, and it's shown to the right here. So we have our flagpole. If angle B is 45 degrees, find the distance from A to D, the top of the pole. Okay, so this red line here that you see is the distance that we're trying to find. So we're trying to find this side of a triangle. So if you didn't know, there are two triangles represented in this image. We have a triangle at the bottom and a triangle on the side. So just to help us visualize both of those two triangles, I'm going to draw them out. So we have a triangle here, and this is a right angle, and it's labeled A, B, C. And then we have another triangle, and it's labeled A, C, D, and we know this is a right angle. And we are trying to find this side, AD. Okay. We also know AB is 25 feet. And we also know CD is 60 feet. Okay, so let's reread the problem just to make sure we have everything labeled. So a 60-foot flagpole is shown to the right. So our flagpole is CD. So CD here is labeled 60 feet. If angle B is 45 degrees, so we know that this is a 45-degree angle, we want to find the distance AD. So that's labeled X. So let's do that. So in our bottom triangle, so the one laid flat, the 45-degree angled triangle, we know that our other angle then has to be a 45-degree angle because all the angles in a triangle sum to 180. So we know that's a special triangle. Okay. And since we know that, we know then that the legs of this triangle are the same. So this would be 25 feet as well. So we know that AC is 25 feet, which is also the same length as AC on our second triangle. So this is 25 feet. Okay, so we don't know the angle measures of angle A and D in the second triangle, but we do know it's a right triangle. And what we're looking for is the length of AD. So we can use the Pythagorean theorem to help us find that length because we know 2 out of the 3 sides. So the length across from the right angle is the hypotenuse, so that's C. And then our other 2 legs are A and B. So using the Pythagorean theorem, A squared plus B squared equals C squared. Okay, I can then substitute my given values and then find X. So A is 60. B is 25, and C is X. So 60 squared is 3,600. 25 squared is 625. So I have 4,225 equals X squared. I can take the square root of both sides. So X will equal the square root of 425. Therefore, x equals 65 feet. Okay, so the distance from A to D is 65 feet.